Every year, Nigeria loses over 30% of its agricultural yield to invisible soil problems, acidity that crops can't survive, and corrosion eating through buried infrastructure that farmers never see until it fails. These are separate problems. They share the same root cause, soil chemistry, and no system in Nigeria has ever addressed both problems at once until now. We are in Nexus from the Department of Metallurgical Materials Engineering, University of Lagos, and that department is not a coincidence. Every material engineer knows that corrosion is an electrochemical process driven by ionic concentration, pH, and moisture, the exact same variables that determine whether a crop live or die.
When soil becomes acidic, it locks out nutrients and stresses crops, but simultaneously, that same acidic high conductivity soil is aggressive, dissolving the buried mouse tail and cast iron pipes that deliver water to those crops.
The farmer sees a dying field. The materials engineer sees accelerating galvanic corrosion. They built a system that sees both simultaneously in real time. SoilGuard is a hardware-software system, an ESP32 sensing node deployed in the field reads soil moisture, pH, electrical conductivity, temperature, and humidity every 3 seconds and pushes that data live to our cloud dashboard. The dashboard doesn't just display numbers, it runs 2 predictive engines simultaneously, a cross-check predictor and a corrosion index calculator based on the Langelia saturation index, a standard metallurgical tool for assessing corrosion potential in water and soil systems, and it connects to a dual tank actuation system, tank A for water, tank B for dilute lime solution that can correct conditions automatically.
This is the live dashboard. You are looking at our field network. The 4 fields on the left are running on simulated sensor data, so the demo is always stable. But this card here, Rice Paddy, is pulling live data from a physical ESP32 node in a real soil environment right now. You can see the sustainability strip at the top. It tracks how much water we've saved versus traditional schedule-based irrigation, and how many precision irrigation cycles the system has managed this session. Let me open the rice field. These numbers are live: moisture, pH, electrical conductivity, temperature, humidity, all updating from the physical sensor in real time. Notice the sparkliness beneath each reading. That's the last 25 data points, giving the farmer an instant thread at a glance. Below the hardware strip is direct pump control. One click sends a command through Firebase to the ESP32 relay, and within 3 seconds, the physical pump responds. The status updates lives.
Good.
Here is what makes SoilGuard different. You can toggle autopilot on if the farmer is going to be away for a specific duration. This is autopilot mode. I set a target moisture of 65%. That value is written to Firebase instantly. The ESP32 reads it on its next 3-second cycle and takes over the pump. It activates the pump when moisture drops below target and stops it when the target is reached. The loop is completely closed. No human in the middle, not a monitoring. This is a monitoring dashboard. This is an autonomous soil management system. Below the sensor reading, SoilGuards pull live AI analysis from the backend. When the AI engine generates a recommendation, whether that's about pH trending, toward crop toxic level or corrosion risk, crossing a threshold, it appears here with confidence score, suggested action, and timestamp. And here is our sustainability feature, one we haven't seen in any comparable system. When our sensor detects low soil pH, instead of immediately recommending commercial lime, which costs money most Nigerian smallholder farmers do not have, SoilGuards presents a ranked list of organic waste alternatives: wood ash, rice, husk ash, vegetable compost, all free, all derived from agricultural waste that would otherwise be burned openly. It calculates the exact quantity needed based on the pH deficit and the estimated plot size. This is waste to value engineering applied directly to smallholder agriculture. Here, this is our materials engineering contribution. The corrosion index panel calculates the Langelia saturation index from live sensor data and translates it into a remaining service life estimate for buried metal infrastructure. A farmer might not know what LSI means, but they understand 38 months of pipe life remaining. That's a language that acts on.
Let me summarize the engineering decision that sets SoilGuard apart. 1. We use Firebase real-time database with persistent WebSocket listeners, not pooling. The dashboard reflects hardware state within milliseconds, not seconds. 2. We built a genuinely closed-loop control system. Target moisture written from the front end, read by the ESP text 2, acted on by the physical relay, sense, decide, actuate, verify, entirely automated. 3. The waste to correction engine creates an economic sustainability model that doesn't require farmers to spend money to fix their soil. It redirects waste they already have. Real-world impacts.
Nigeria has approximately 36 smallholder farmers. Soil acidity affects over 70% of arable land in southern states. Corroded irrigation infrastructure fails silently and is replaced at enormous cost. SoilGuard addresses both with a single system that costs a fraction of traditional soil testing services, run on solar power, works without consistent internet, and gives farmers the ability to act, not just observe. From metallurgical and materials engineering, we didn't just build an app, we applied corrosion science, electrochemistry, and material degradation principles to one of Nigeria's most urgent infrastructure problems.
SoilGuard, predict it, correct it, automate it. We are Team Nexus.
So this is the SoilGuard project that we're working on. So basically, this is the ESP microcontroller that we're using to control this whole setup. So what we're basically measuring is the temperature and the humidity with this sensor. This is DHC sensor used to measure the temperature and humidity of the whole farm environment. So we're also measuring the moisture. This is the soil moisture sensor that we're going to be using, and this basically we're using it because it has a high capacitive resistance, meaning that it won't corrode easily on a farm setup due to water and all those other things. So basically, this is the water tank that we're going to be using, and relay switches for the switching of the pumps and turning on the pumps and turning on them off. This is for the one setup, and this is for another setup. So that's it.